I've taken up too much of your valuable time. Right. We're going to find limits using limit laws. And if you remember, there was evaluate, factor in, cancel. I guess I should write them down. So we're going to do examples of all of these. Evaluate, factor and cancel. I'll put you in a spot here. Can anybody remember the funny name for the ones that had square roots on them? And it started with a C.
Conjugate. Conjugate.
Well done. Yeah, you're good. I know what you mean. Can't really remember what the fourth one is. So the fourth one is basically just algebra, isn't it? Simplify. Doesn't really have a name because it's really the catch-all for anything that doesn't fall into the first three categories. So what essentially you do in the fourth one is that you find some technique in algebra to simplify the fraction, hopefully get some cancelling and get your answers. So I am going to show you some examples of each of these four types, all going to be from section 2.3, and that's kind of our goal for today. This one is similar to question 2, and we're being asked to find the limit as x tends to -3 of 2x plus 1. And yes, this question is so silly, I mean, it's almost not worth being asked, but it's there for completeness, I guess. In the evaluate method, so I guess I should write down what method I'm using here. In the evaluate method, essentially it says, look, if you can plug x equals -3 into this expression and you get an answer, then that's the limit. So in this case, it's 2 lots of -3 add 1, -6 add 1, and the answer would be -5. You should always do that as your first strategy. I'll just plug the number in and see if I get an answer. If you plug the number in, and typically these should be fractions, but in this case it's not, you'll get 0 over 0 most of the time, right? The indeterminate form. And that's why you have to use, you know, that's why there is some other techniques. That's why you have to use these. The next one is an evaluate, but it's a little bit different. I haven't talked about this yet. So this one is similar to question 1. Suppose I tell you that the limit as x tends to 3 of f of x is 10. And I tell you that the limit as x tends to 3 of a different function g of x is -2. And I tell you the limit as x tends to 3 of a third and final function h of x, and it's going to equal, I don't know, 4. You can use the fact that you know the limits of these to find the limit of any expression that uses f, g, and h. For instance, f of x times g of x divided by h of x. So can you imagine that was a function, this was a function, this was a function, and you multiplied the first two and you divided by the third, and you wanted to find their limit as x tends to 3. According to the laws of limits, I'm normally not going to write this down because it takes too long. You are allowed to find the individual limits and do the same calculation. Normally, I would not write this line down. I would kind of think it in my head, this is what I'm doing. Okay, that guy is 10 times this guy, which is -2, divided by that guy, which is 4. What does that give me? negative 20 over 4, the answer is negative 5. So the laws of limits could be probably described in this way, that if you want to do the limit of a combination of functions, you can use the individual values to get your answer. So how about this one? So this time I'm going to go overboard. I can find the limit of that ugly expression. And it's not that difficult. Because won't it be the square root of that guy squared over this guy, take away that guy. So it's going to be the square root of, okay, let's change it to an add. 100 over 2, square root of 50, 5 root 2. Why did I change the minus there to a plus?
You don't like imagining numbers?
Yeah, we just don't want them. As far as you are concerned, in Calc 1 to Calc 4, imaginary numbers have disappeared. Nobody knows who they are, nobody's seen one, nobody expects one to appear in an answer, right? So we keep away from those darn things. You can imagine they cause trouble, right? So we just, let's not go there, essentially. Are you comfortable about evaluate? I don't really want to spend a lot of time in those. Would you agree that if you can plug in a number, you can get an answer? And if you tell me the value of functions, I can do any expression using these, probably with one or two exceptions. If I did a combination and it was a fraction and I got 0 over 0, would you agree that I wouldn't be able to tell what the answer is because it's in determinant form?
Excuse me.
Right. So imagine I did some in the top that ended up being 0, some calculation using these on the bottom that also being 0. So that would be a bad idea. And I would have problems with that as well. Can you imagine there might be a situation where the bottom part, right, this bit here ended up being 0. 7 over 0 causes a different kind of problem than 0 over 0. 0 over 0 in determinant form, if we know enough information and we do some work on it, couldn't that be 4? Couldn't that be 0? Couldn't that be infinity, right? Could be anything. 7 over 0, we know a little bit more about that. Isn't 7 over 0 essentially going to generate a vertical asymptote? And so I know the answer is going to be plus infinity, negative infinity, or 0. And I don't actually know which that is because 0 is a neutral number. It's neither positive or negative. 0 is at the boundary between the two. And I don't know if that's a positive 7 over a positive small number or a positive 7 over a negative small number. Won't that, in fact, decide whether it's plus or minus infinity? You know, it could be a volcano, right? It could be a hole in the ground, right? But it could be one of each. So don't know in determinant form. The good news is that won't happen if it's an evaluate. If that does happen, we'll use one of these techniques. So let's look at our second group. And there are lots of them. They're very common. Let me pick one. Okay. This one is similar to question 4. We're going to do the limit as t tends to 7. T squared, take away 2t, take away 35. T take away 7. Now, I happen to know that's factor and cancel method, but let's suppose I didn't. Let's suppose that was the question, I'm just looking at it. My first strategy is plug in 7, see if we get lucky. So if I plug in 7, I might get 4/3. Well, that's the answer. Right? I don't need to do any clever algebra, right? According to the evaluate method, if you can plug in a number and you get an answer that exists, then that's the limit. Of course, you're going to trust me that that's 0 over 0. Agreed? Just pretend I know it, and it is. So in the factor and cancel technique, you factor things. Well, there's not a lot I can factor that guy by, but the top is a quadratic, a trinomial. And in this case, aren't you looking for two numbers that multiply together to give you negative 35? And when you combine those same two numbers, you get negative 2. And a negative 7 and a plus 5 come. Do you want to see a little trick? Yes, you want to see a little trick, don't you? Can you imagine that that polynomial up there had a ridiculously ugly last number, like 360? Now, can you imagine how many different combinations there are for a really big number like 360? Because we know that this technique is going to work, don't I know that one of the top has to be the same as the guy in the bottom? So when I'm factoring that, I already know one of the answers. Don't I know one of the answers is 3 minus 7? And that means I only need to figure out who the odd guy is, right? The other guy is. So if you're factoring, right, you already know half the answer. Sorry again, Robin?
What if it doesn't divide evenly into the number?
Then the question won't be factorable, in which case it probably would have been an evaluate question, and when you plugged it in, you'd get a number, and you wouldn't need to factor anyway. It's going to have to factor, right? Or the question, where am I going with this? The fact that you get 0 on the top and 0 on the bottom doesn't not mean that there's a value of the variable that makes the top 0. And if that's true, it means the thing has to factor. So it will always factor. You won't get an awkward number. Now, kill me, cancel it. And there you get the limit as t goes to 7. Technically, t plus 5 over 1, but we probably wouldn't write the over 1 thing. And at this point, the original has now reduced to a really easy thing, which we can then evaluate in the usual way. And if I plug 7 in here, we get 12. Are we good with that? Does that seem a reasonable process for finding limits? Factor the thing, cancel. Let's see if I can find yeah, this one will do. It's the limit as x tends to negative 4 of 3x squared plus 11x, take away 4 on the numerator, and x squared take away 16 on the denominator. Okay, no pressure, you've got 1 minute. You do it first. Factor and cancel and find that limit. You know, we should have been a quiz show where they've got that really annoying music goes do 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 do. Put some more pressure on you.
Please make a Kahoot. I love Kahoots so much. They're so fun.
What's a Kahoot?
That's the quiz I think you're talking about, where it's just like you have to, it's like a multiple choice online quiz.
Yep.
It's so fun. I
Oh,
love
okay.
those.
So you're thinking this is the quiz show Kahoots, right? Okay, last 5 seconds. Okay, this is going to get the old cobwebs brushed out. I'll take a volunteer just for the top, and I'll pick a different volunteer for the bottom. What about 3x squared plus 11x minus 4? Go for it, Robin.
3x minus 1, x plus 4.
Okay, it's correct. Let's do the check. 3x times 4 gets you positive 12, and then take away 1. Nailed it. Now, x squared minus 16. Someone else. That's the difference of 2 squares. Come on, don't be shy.
X plus 4 and x minus 4.
Right. If you look carefully, do you see there's a x plus 4 match? Right, that's the cancel part coming up now. The new question, the new limit, is a lot nicer than the original. I'll now plug in -4. So 3 lots of -4 take away 1, and -4 take away 4. What's that? -13 over -8, and the answer is 13x. I'm sure you're aware of this, but I'll just reinforce it. In mathematics, we like answers that are fractions to be written in this format, and we don't like them to be written like that. And it's a convention, but everybody in math, at least advanced math, agree that that's what you should do. I believe in America you call them improper fractions. And I believe you call these guys mixed fractions. Are those the terms that you're familiar with?
Yeah.
That would be called an improper fraction. Right. I like names to tell you a little bit about what they're about. So I like names like evaluate method, factor and cancel method. I'm not too keen on the conjugate method because it doesn't really tell you anything unless you know what conjugate is, right? I don't mind the name mixed fraction because it is kind of mixed, isn't it? It's got some whole numbers, there's some fractions. That's fine. I do not like the name improper fraction because in a funny sort of a way, doesn't it sound like you're doing it wrong? That's the improper way to do it. Right? We don't call it improper fraction back home in Scotland. And I can't speak for England, but I'm pretty sure they're probably the same. We have a much better name for that fraction. It's called a top-heavy fraction. Would you agree that's a better name?
Yep.
Yeah. Names should be not just labels. Shouldn't names at least help you remember what the darn thing is? And when I think top-heavy fraction, I'm pretty clean in my brain. Big number, little number, it's top-heavy. Easy to remember, kind of makes sense. Improper fraction, I don't know what's improper about it. It's just as proper as any other fraction. Doesn't help me at all. So, just a little idiosyncrasy in the world of math. I really would like America to sometimes maybe look at other countries, and if they have a better name for something, maybe slowly introduce it. That would be nice. Okay. As far as this factor and cancel method goes, does things look good? As long as you're good at factoring, it's going to work. That's the algebra ones. It's the conjugate ones. I'm just scanning through some more conjugates. Oh, I like conjugates, some algebra ones. Okay, that's enough of those ones. Are you cool with that being all I've done, or do you want me to do another one? Are we cool with cut factoring, or can I move on? Move on? Okay. I'm trying to think of a name that I might use for that. I know if I was starting from scratch, I might call this the square root fraction method. I'd give it a name like that, just something that would try and remind me that you use this method only in situations where there's a square root involved, right? And that's where they're designed to work. So let me pick some examples. Pick one in the top, I think. Yeah, okay. This one is like question 11. So we're going to do the limit, as h tends to 0, of the square root of 64 plus h, take away 8 over h. A little bracket around it. Now, this is a classic example of a situation where the conjugate method would be used. Do you see the square root I keep nattering on about, right? It's pretty obvious there's a square root involved. If I plug in 0, can you trust me? You get 0 over 0, the indeterminate form. Just in case they're sneaky and give you a square root question where you could just get the answer by plugging the number in, right? Where the evaluate method works. I mean, it wouldn't be hard for me to do that. For instance, see if I put h plus 1 in the bottom and maybe call that plus 8. Wouldn't that work? You'd be able to get the answer as a number. You wouldn't need to factor anything. I don't think they did that, but just in case. Now, the conjugate method, to remind you, you multiply this fraction by a special version of 1. And what makes the thing work, or the process work, is that essentially, if you multiply a fraction by 1, you're not changing anything significant about it, right? It's the same fraction, it just looks different. And the version that we use is the guy that's got the square root, which is this guy, but instead of the takeaway 8, it's the add 8. And that guy is called a conjugate. Let's see what this looks like. The denominator in this case just gets written down. You don't need to do anything. You don't need to distribute it or whatever. But the top two guys get foiled. So here it goes. The square root of 64 plus h times itself gets you 64 plus h. When you do this guy times plus 8, you get 8 square roots. If you go this guy times this, you get take away 8 square roots. And the number times itself, you get take away 64. Are you all happy about the FOIL? F-O-I-L. You comfortable about this? I know this is only the second one that we've seen, but have you noticed that the same thing happens? Don't these two guys in the middle always cancel each other out? And so what you're going to be left with is the limit as h tends to 0 of, in this case, 64 plus h, take away 64 over this stuff. And then some more nice things happen. The 64s cancel. And at this point, I can cancel the h's. So what we are now left with is this limit. And this limit is good, because can't we just plug h equals 0 into it and get an answer? So let's see what we get. 1 over the square root of 64 plus nothing is still the square root of 64. And 8 add 8 is 16. So 1/16 is our answer. Now let me try and sell you on why the algebra techniques that we've been doing today are better than just plugging into Desmos and looking at the graph at 0, or doing a big table of values, you know, and doing the 0.0001 and negative 0.001 techniques. This fraction here, this is the exact answer, right? This is what the limit of this particular thing would be as h tends to 0. If you try to do it on Desmos, well, let's not do 1/16. Let's suppose that the answer was 3/48, right? Could you imagine it could be, right? You will not see 3/48 in Desmos. And if you do a table of values, you will not see 3/48. Won't you see, and I'll do this. Actually, that's a bad choice. So I'm going to change this to 49ths. Won't you see 0.06122448898?
Yeah, just a nasty
Which, by the way,
decimal.
is what 3/49 says. So again, Robin?
Yeah, just a nasty decimal, usually.
Yeah, and there's no way in the world, I think, that you'd be able to look at that decimal and say, oh yeah, that's 3/49, right? Because couldn't it be 457s and 1,739s and who knows what else? And if you want to get a precise, exact answer, essentially, if you want a fraction, won't this not be good enough? So if I sold you, and secondly, I think, and most people I think agree with me, that isn't algebra just prettier and nicer than grabbing a calculator to 10 decimal places or hurting your eyes as you stare at a graph to try and see how accurate you can read a point of? So I'm trying to sell you on the conjugate and, well, actually all the methods. So here is the next fella. And this one is the conjugate method, and it's question 12. And it's the limit as x tends to 2 of 2 take away x, the square root of x add 2, take away 2. Now we're going to do the conjugate method. How do I know there's a square root? You see that square root of x add 2, conjugate method. Now, the guy that's going to generate this is him. Have you noticed now it's on the bottom? There's no reason why it needs to be in the top. Can't the conjugate guy be along in the bottom like it does here? And so it's going to be the square root of x add 2 plus 2. So in this case, I'm going to leave the top alone and only FOIL out the bottom. Oh, have you noticed that these two guys are difference of two squares? You know, like a plus b and a minus b, isn't it? Something take away something, the same something add something. And when you do a difference of two squares, don't the two middle terms always kill each other off? Now, if that is the case, I can shorten my workload a little bit. If I FOIL this out, won't I just get the square of x add 2 times itself, which is x add 2, take away 2 squared. There. Do you see I've just saved a line of working? Are you happy about that skipped line of working? How I could do it? This times this, you get the square of x add 2 times itself, take away that. It's a bit like, you know, a squared take away b squared. And if you like that, then I suggest you should do that in your own working. If you don't like that, well, you put in the FOIL version first, and then you get the answer. It's up to you what you're most comfortable with. So it's now going to be the limit as x tends to take away 2, this guy, over this guy. No, it is not a mistake. You're probably saying, where's the cancel? Where's the x minus 2 in the top and the bottom? How come it ain't happening? You said it would. I don't trust you anymore. Look again. Can you cancel this guy with anybody? You can. Agree, Cynthia? What do you get when you cancel x minus 2 with a 2 minus x? They do cancel out, but what's left behind?
-1.
-1. So what we now have is the limit as x tends to 2 of negative this guy. Technically over 1, but I won't write that. And that's going to give me what? That's going to give me little negative the square root of 2 add 2, which is what the square root of 4 add 2, 2 add 2 is 4, and the answer I'm going to get is -4. Are we good? Still work. Now, pretend a totally different question. And we did all the work. And that's what we were looking at. Right. So pretend totally different question, but we got to there. And you might be saying, where's the cancel?
Factor 3 from 3x plus 6.
So be on the lookout for little fiddly things like that, right? That you may have to pull out a common factor of 3, or it might cancel out, but it leaves behind a -1, right? Little things like that, but it will cancel. It's the method is designed that that's what's going to have to happen, right? So you know it must happen. So you just have to be on the lookout for it. I guess that, well, in my case, couldn't you just sometimes screw up in your adding? You know, just check your working, and that might be the reason it didn't quite seem to match up.
And at that point, it looked like you could actually just have stuck the 3 in there because it would have had a 1 on the bottom. So you could just go ahead and stick the limit in there.
Yeah, you'd cancel that and you'd be left with 3 lots or whatever it is and get your answer.
Yeah, but I'm just saying up above 1, you could just stick the 3 where the x plus 2 is, and you would have down. Yeah, right. Yeah, hold on.
I'm here.
No, just
Okay.
wait. Down 1 more. Keep going. Keep going. One more. Right there. Right there, you can stick the 3 in for that x plus 2. And you can stick, you know, so it'd be 3 times 3 plus 6, square root of 3 plus 2 plus 41 over 3 plus 2.
Oh, yeah. I should have changed this guy here to -2 to cause a problem.
Oh, okay, okay,
But what you said was true.
yeah, okay.
Yeah, because there would have to be a 0 on the bottom for these questions. Otherwise, it would just be an evaluate. I'm trying to think of it. There is one I wanted to say. I knew it. I just can't find it. If not, I'll make it up. Here it is. I found it. This is the conjugate method on steroids. It's going to be the limit as t tends to 0 of the square root of 3 add t, take away the square root of 3 take away t, all over t. Now, if you plug 0 in here, you get square root of 3 take away square root of 3 is nothing on the top, nothing on the bottom. Would you agree that there are 2 square roots? Normally, you just get a square root and a number or something like that, right? But here we have 2 square roots. It doesn't change the method any. You just have to be a little bit more aware that the conjugate is this guy plus this guy. Does that make sense? The same guy, but we are plus. The fact that both of the guys are square roots doesn't really change too much. So it's going to be the limit as t tends to 0. I won't do anything to the bottom this time. And if I FOIL the top, can I do the shortcut and just say it's the first guy squared, take away the second guy squared? So it's the first guy squared. So the square root of 3 plus 2 times itself gets you this. Take away the second guy squared. So far, so good. That times that gets you 3 plus 2. Negative that times positive that gets you, subtract 3 minus t. That becomes the limit as t tends to 0 of they cancel out and those combine. There's my cancel. Okay, plug in 0, what do I get? I get 2 on the top, and I get the square root of 3 plus square root of 3. Okay, let's be nitpicky here. You know that's not going to be the right answer. Well, let's rephrase that. It is correct numerically, but it's not the right form of the answer. Agreed? So let's go hunting for what would be considered a better version. Would you agree that that's a little bit better looking? Is there anything I could do to make this pretty? Go for the obvious.
You can cancel out the 2's and make it 1 over square root of 3.
Right. And WebAssign is pernickety sometimes. I've seen questions where you type that in and it's quite happy. But
Sometimes it
can you
does not
remember that?
have the square root in the bottom.
And sometimes it does not, right? It depends on the problem. And so that guy, although technically is correct, it's considered better form to, it's called rationalize the denominator. Essentially, you multiply by that special version of 1, and can you see that that's your final answer? I'm sure WebAssign will always take this. It might or might not, depending on how it feels on that day, take the 1 over root 3 answer. So I don't want you to do all the hard work, get a little red cross and pull out your hair and say, well, I thought I knew how to do this conjugate, but evidently I haven't a clue because I'm wrong. When you were right, I mean, 99% right. It just wasn't that guy. Okay. Now, let me give you a little story. Say hi while this is going on, about why we are particular in math, why we are so fussy. Now, you know, we never write 1x, don't we always write x? You know, and if you wrote 1x, people would say that's not really the right form. Right? You don't write 4/6, you write 2/3. You should write 7/3, and you shouldn't write 2 1/3. Right, we have all these little pernickety rules. You gotta write it this way, not that way. We could say that this was a rule. That one's not always obeyed, but it is a rule. That square roots shouldn't have, fractions should not have square roots in the bottom if they can be avoided. So you might think, why are we so pernickety? Why are we like a lawyer, you know, just being fussy like that? It's very important that when you do a subject like mathematics, that it is international. If you go to Germany, that guy will turn into that, right? Everybody in Germany will do that. Everybody in Germany will write X, not 1x. Everybody in Germany, I hope, would do this and not that, and so on. And in France, and in China, and in Russia, and in the Cameroons, everybody in the math world does the same thing. It makes communications between mathematicians a lot easier. That if I do my working and my question and I write it down, and you show it to someone who comes from a different culture in a different country, they will have done it the same way and got the same answer. It makes verification very easy. So let me show you what happens when you don't do that. What have I just written down here where my finger is pointing?
3.7.
0.7.
And what have I written over here?
3 times 7.
Right. One of the things in mathematics that has not been standardized is what, for want of a better word, what does the decimal point mean when you put it in certain places? Because in Britain, the decimal point is in the middle. So if I write 3.7, but an American sees it, doesn't he think I've just written 3 times 7? Couldn't that be really, really dangerous if an American engineer was talking to a British engineer and they were just doing some calculations with some numbers and writing down what they were doing? Couldn't you easily mistake something I was writing if you're an American, right? So if you write down 3.71 or 3.71, you see, it looks very similar to both groups, but it might have a totally different meaning. One of them means 3 times, the other is a decimal. And if you are French, it's 3.71. That's what happens when we don't make up pernickety rules. Because if you don't have these rules, this is how we all agreed to do it. You can see how hard it can be eventually if everybody made up their own rules about how certain things should be written. Where does a decimal point go? Do you even use a decimal point? Can you just imagine the confusion that would be caused in the scientific world? Because mathematics is the language of science. That's how we engineers communicate information. And if you're going to communicate it with someone from a different country, a different language, you want to be able to do it in a way that you're pretty sure that when you write something down, they're going to see it the same way. And that's the reason why we are pernickety. And I've just realised I've used that word a lot. Is pernickety one of my funny British words, or is it a word that Americans know?
I think it's one of your funny words.
British words. Is it now going to become one of your American words that you can use when you've got a conversation? Because what word would an American use instead of pernickety?
Mom
Picky?
actually says the same thing, just persnickety is the only change she makes to it. But she says the same thing all the time.
Ah, so it's probably a British word that got mucked about with when it hit America,
Probably.
like aluminium turned into aluminum. Don't know why that ever happened, but evidently it did. Okay, guys, I've kept you far too long, but say hi. Well, you should have said that anyway, but just in case you haven't, said hi and bye-bye. And I'll hang about for a few minutes if there's any questions.